Okay, so this is a continuation of the discussion that we were having at the end of class. So picture an inclined plane, and we've got a distance of 4 meters, and we want to get this box from the floor up 4 meters. Now, as I said in class today, we could just bend over and pick up that box and just lift it up to the top of that 4 meters. Actually, that's pretty high, so you wouldn't be able to do that. But anyway, the other thing we can do is build a ramp and slide the box up the ramp. The force that the box is pulling on is the same, regardless of whether we pick it up off the floor and lift it up that distance, or if we slide it up the ramp. The force of that box doesn't change, so that's the resistance force. But it's less effort for us to push the box up the ramp than it is to pick it up. So we gain an advantage in terms of the push that we're putting into it, or the force we're putting into it when we slide it up the ramp, but we have to slide it a longer distance. So that's what mechanical advantage is. The way that this diagram has it pictured, they say it's the load force divided by the effort force. In class today, we use the term resistance force for load force. So anytime you see load, just think of resistance, and I'll remind you. So for example, they say that the wheelbarrow has 300 newtons worth of force in it. And then when we pick up the wheelbarrow, we're only putting 100 Newton force on our effort to pick up the wheelbarrow. But look at how far the bottom of the wheelbarrow has moved. It's only gone up 100 millimeters, which isn't very far. But when we picked up the handles of the wheelbarrow, we went 3 times as far when we picked up the wheelbarrow. So our effort, again, was spread over a longer distance, and that's where we gain mechanical advantage. In this case, it's a mechanical advantage of 3. Keep in mind that a mechanical advantage of 1 is the same as just picking up the resistance, okay? Let's look at it this way. This is a first-class lever. It's a first-class lever because the lady on the left has the effort. The fulcrum, they call it a pivot here, but it's a fulcrum, is in the middle, or actually in this case closer to the resistance, and the load is at the far right-hand side, or the resistance. So notice when this lady pulls down on the lever arm all the way to the floor, it's going to travel all that long distance from basically the point of her nose all the way down to the floor. But the resistance, isn't going to go up very high. It's only going to go a little bit. So there's a great mechanical advantage there because the effort arm is so long. Okay, so make sure you have this information in your notes. Mechanical advantage can be measured 2 different ways. In class, we were only able to talk about one way to measure that. We're going to start with the force first. It's the resistance force divided by the effort force. If you need to pause the recording and write that down, then do it. Another way to calculate mechanical advantage is the effort length divided by the resistance length. Notice that those 2 equations have been turned around depending upon whether you're talking about force or you're talking about length. Let me show you what this really looks like. So again, we have the formula on the top, and we're going to talk about the force first. So let's say we have a resistance force of 12 newtons. Today you guys were working with stuff at about 6 to 8 newtons. And let's say that our machine gave us an effort force of 3 newtons. So when we take 12 and divide it by 3, we have a mechanical advantage of 4. That's pretty good. Then we can also determine the length, the mechanical advantage from the length. In this case, let's make the Let's make the effort length 80 centimeters and the resistance length 20 centimeters, which would be more like this picture right here. We've got this really, really, really long effort arm and a really, really, really short resistance arm. So then we take 80 which is the effort length, divided by the resistance length of 20, and again, we get a mechanical advantage of 4. Now, this is very, very, very simplistic. When we really dial into this, we actually talk about ideal mechanical advantage and actual mechanical advantage, because there's some forces that are lost to other types of energy in simple machine systems. We're not going to worry about that at the moment, okay? So that brings us to a concept that I wasn't able to get to in class today, and that is when we define work in science, work is defined as a force times a distance. So if we go back to the data that we collected today, we were measuring forces and we were measuring distances. So we obviously have done work in terms of science, but it's a specific formula that we apply when we talk about work. It's a force times a distance. Let me show you what that looks like. So let's go back to our same example from before. So let's take the top example. We have a resistance force of 12 newtons. We have an effort force of 3 newtons. And then we also had the resistance length of 20. Let's go with that one. So then work we know is force times distance. So let's take the 12 Newton force from the top equation and put it on the line. We're going to multiply that now times the distance that the resistance went. But we're going to use 0.2 instead of 20 centimeters because 0.2 is measured in meters, so it's 0.2 meters. When I multiply those two numbers together, I get 2.4, and now the units are called Newton meters. Newton meters, okay? That's the amount of work that was done. 2.4 Newton meters was the amount of work that we did. We can also do it for the other way. We can do it with the effort force. In this case, the effort force was 3 newtons. Remember, that's a pretty small force, but we did that over a really, really long distance, and that becomes 0.8 meters. When I multiply those two numbers together, I get 2.4 Newton meters. So that's how we calculate work. All right? What I would like you to do today as homework is I'd like you to take a look again at your data table. I would like you to calculate the mechanical advantage for each of the situations that you gathered data for. You have resistance forces, you have effort forces, figure out those mechanical advantages. You have effort length and you have resistance length, figure out those mechanical advantages. Then also figure out the work that was done in each of these different investigations that you did. And you may need to leave this screen up to remind yourself how to do that, but it's simply work is force times distance. So if it's the work of the resistance force, then you take the resistance force times the resistance length, and that will give you the amount of work that you did. Or the effort force times the effort length, that will give you the amount of work that you did. Okay? So do all that. Have it in class next week, although we won't go over it until 2 weeks from now, but that'll, at least you'll be ready for what we do 2 weeks from now. Remember, I will be gone next week. You will have a substitute, and you guys are going to work on your gravity cruisers. Thanks. See ya. Bye.